welcome back to my lovely people, and thank you very much for watching this lecture video. It's another lovely day, and I'm here with another lecture from organic chemistry. In this lecture, we're going to go through ethers, and ether as a functional group, it has an oxygen that attached to two carbons. Those two carbons, they can be identical or not. And ether, as you see here in this slide, we can find ether in vitamin E or other very common medicines. And the first thing that I'm going to go through it will be the naming of ethers. There are two ways to name the ethers. One way is let's name each substituent, and at the end we will add ether to the name. That's one. And the second one, we're going to turn the smallest, the smaller substituent that's attached to oxygen as a substituent, and we will call it alkoxy. And we say alkoxy is attached to the main chain. So let's go through those two. And so, as I said, the first method is to name each substituent. I have ethyl and methyl. The priority is going to go with ethyl. So I'm going to say I have ethyl, and then I say I have methyl, and I will add ether to the end to say that this is this compound is attached to methyl and ethyl group. Another one, we have tertiary butyl and methyl. Tertiary butyl will get a priority, so I go tertiary butyl because of the B letter, and then we have the methyl, and I will add ether to the end of the name. So it will be tertiary butyl, methyl, and ether. And this is one method to name them. Another method is to name them, again, let's treat one substituent that's attached to oxygen as just one substituent, and so we're going to call it the alkoxy. And the one with more carbon, it will be the main parent or the main chain, the main chain. So I go 1, 2, 3, 4, 5. This one is pentane. And on the left side, I have two carbons, 1, 2. So I'm going to say this one, it will be ethoxy. Okay. And ethoxy is attached to pentane. So it will be ethoxy pentane. Okay. And that's going to be the right name for it. Okay. Let's keep practicing more examples. And what do we have here? We have two methyls and one chloride, and also we have an ether. So how about this? Let's find or highlight the main chain. Okay, this is the main chain. And next step, we're going to highlight all the substituents. That's one substituent. This is the second substituent. And here I have two substituents there. Okay, let's label the main chain. The main chain, we're going to say 1, 2, 3, 4, 5, 6. So I have 6 carbons, and I have ethoxy. Start with the E. This one is a chloro. Start with the C. And next I have methyl. And the methyl start with M. So the priority is going to go to chloro, and the chloro is sitting on the second carbon. So we say 2 chloro. Next, on the first carbon, we have ethoxy. So we say 1 ethoxy. Next, on the third carbon, we have 2 methyls. So I say 3 and 3 dimethyl. And then we have 6 carbons. So it will be hexane. Okay, and that's going to be the correct name for it. Okay, next one. Okay, let's check both sides of the oxygen. This is our oxygen. We have cyclopentane and methyl. So one way to name it is to say, okay, this group is cyclopentane. Okay, I want to say this one is attached to oxygen. So how about this? Let's get rid of E and replace it by YL. Cyclopentyl is going to be, forgive me, cyclopen, what did it do? Okay, cyclopentyl. And this one, it will be methyl. There we go. Methyl. Okay, so the way we're going to name it, we will say cyclopentyl, and then methyl. Okay, and next we say ether. Okay, we add the ether to the end of the name. Okay, and so it will be cyclopentyl, methyl, ether. Or how about this? Okay, another way to name it is to treat entire of this one as one substituent. In that case, we have methoxy. Okay, methoxy substituent attached to the cyclopentane. And so I'm going to say, and I have methoxy substituent that attached to the cyclopentane. So it will be methoxy cyclopentane. And that's going to be the second way to name it. So we got two names for same compound. Next, we have two identical substituents, and both of them are methoxy. So I'm going to say 1 and 2. I have two substituents there, and I'm going to say 1 and 2 go dimethoxy, and this one it will be ethane. Okay, 1 and 2 dimethoxy ethane. We have a cyclohexane. This is going to be the main chain or the parent, the main chain or the parent. And so it will be cyclohexane. And look the position of the two substituents. The one of them is up and the second one is down. So we're talking about trans configuration technically. And we have methoxy groups. So I'm going to say on the first, on the first and the second one, I have methoxy groups. So 1 and 2. Okay, I go dimethoxy. Okay, 1 and 2 dimethoxy. Next, I have cyclohexane, so I go cyclohexane. Okay, I want to say that their position is a trans. So here, right at the beginning, I would say trans 1 and 2 dimethoxy cyclohexane. Okay, next. I have two substituents that they are not identical. One is ethyl and the second is methyl. Priority goes to ethyl. And so I go, these two are trans. So here we go, trans. Next, okay, we say this is going to be 1 because of the ethoxy. And this one will be 2. So we say 1 ethoxy. And then 2 methoxy cyclohexane. So trans 1 and 2. Trans 1 ethoxy 2 methoxy cyclohexane, and that's going to be the right name for it. Okay, next one we have a substituent is here. That's a methoxy, and we have a function. We have here a function, and that function is going to be functional group is going to be double bond, and we say the priority is going to go to double bond. So how about this? Let's just label it, and I'm going to start from there. I say 1, 2, 3, 4, 5, 6. Okay, the way you label it, you should give the double bond the smallest possible number, and you have to cross the double bond. Okay, both carbons. And so in this case, we say on the fourth. Okay, on the fourth one, we have a methoxy group. So I say 4 methoxy, and then I say cyclo, and then I say hexene because we have a double bond. And no need to say position of the double bond because we already said how far the methoxy group is from the double bond. Okay. Next one, we have a good number of, like a function, we can say functional groups here. We have alcohol, methoxy, and also we have halide. And when it comes to alcohol, it will get the priority, the first priority. So that's going to be number 1. And so the way you're going to label it, you start from a side that is closer to the alcohol. And so you say 1, 2, 3, 4, 5. Now I have 2 here. I have one substituent. That's going to be the methoxy. The second substituent, it will be the bromo. And of course, I have alcohol. So how about this? And we're going to say we have bromo. Let's write the name here, methoxy. And this one will be bromo. Bromo will get a priority over methoxy. And so we say 4 bromo. Next, say 3 methoxy. Okay, we have 5 carbons. Okay, so we can say 2 pentanol. Okay, 2 pentanols. That's one way to name it. And so 2, and then say pentanol. Okay, let me move this one a bit here. So 2 pentanol. Okay. And so this is one way to name it. Another way is to technically move position of the sorry, 2 there between technically the pentane and the OL, and just simply to say that like I have 5 carbons, so I say pen, and then and I'm going to put the 2 after it to show position of the position of the alcohol. Okay, so let's keep it as it is. So I go 4 bromo 3 methoxy 2 pentanol. Next one, I have a benzene ring. In the benzene ring, it has 6 carbons, and as you see, and we have also 3 double bonds, and the double bond can keep changing position. And in order to say we have a resonance structure, in order to say the double bond, it can be here, there, and there. So as you see, I change position of the double bond, and then instead of that one, chemist has tendency to draw a ring inside the cyclone and the hexane to show that's that one is a benzene molecule, and there is a resonance structures, or we have resonance for double bonds technically. And if this ring is not attached to anywhere, the name for it will be benzene. But if it's attached to somewhere else, you can call it phenyl. Phenyl. Okay. So now in this case, I have this one, a group that's attached to oxygen. Also, I do have a methyl there. How do I name this compound? So I have phenyl versus methyl. Okay. Prior to it goes to methyl, so we will say methyl, and then phenyl ether. Okay, and that's going to be the correct name for it. And this is going to be the end of this lecture, and thank you very much.